Hi, my name is Aarushi Pore. I'm a sophomore in the Medical Professions Academy at Olathe North High School, and the name of my project is The Use of Bacteria to Combat Pollution. So when plastic was invented in 1907, it proved to be very revolutionary because it was very sturdy, it was very cheap to manufacture, and it was very readily available. So this was very revolutionary for the commercial industry. This allowed for many products to be made that were very cheap. And although it was the invention of plastic proved to be very phenomenal, it proved to have brought severe consequences on our environment and our planet. So the plastic PET specifically, it's used in many things like to make toys, to make water bottles, and clothes. And like I mentioned before, it's very useful, but we find that all of these products, they are found just roaming around on our land, and they're found washed up on our shores and in our oceans, and it's just polluting and harming the earth. So it has been estimated that there are more than 5 trillion pieces of plastics in the world's waters alone. This number isn't even accounting for the amount of plastic that is on the land, just on the water. And when we're talking about the water, many big pieces of plastic, like plastic bags and water bottles, they can get caught in the necks and the limbs of wildlife, and smaller pieces of plastic, like microplastics, which are a form that plastic takes when it breaks down, they can enter the stomachs of our wildlife through they eat the plastic, but they don't know that they're eating the plastic. So they enter the stomachs of our wildlife and it can go up the food chain. So if there are little to no solutions to make a great impact to fight against this problem that we're facing, many negative consequences will occur. Like I talked about, our earth will be polluted even further. And like I talked about, the food chain, it can reach to us eventually. If they're like fish that are eating plastic unknowingly, then it can reach us. It can just harm the earth and everyone in it as a whole. So this chart it shows all of the bodies of water, the major bodies of water in Earth, and it's showing the amount of plastic that is in the bodies of water. So as you can see, it's a very, very large amount. So what is Ideonellus acaiensis, and why am I including this in my presentation? So in 2016, when Japanese scientists were collecting a sample of PET contaminated sediment near a plastic bottle recycling facility, they discovered Ideonellus acaiensis, which is a bacteria that can break down PET plastic and shorten the process of breaking down of plastic by producing two enzymes. So just for some background information, PET, which is short for polyethylene terephthalate, is made up of two compounds, which are ethylene and terephthalic acid. So what these two compounds do is they bind together through a process called polymerization, and they form the plastic PET. And PET is made up of linked chains of MHET, which are those two compounds binding together. And when there are more of those compounds, that's when PET is formed. So what Ideonellus acaiensis does is it breaks down PET into MHET by using two enzymes, which are called PETase and MHETase. So carbon in those compounds, they become digested to fuel Ideonellus acaiensis, and it allows for the bacteria to keep on breaking down the plastic even further. So what this specifically does is bacteria, it helps speed up the process of hydrolysis, and hydrolysis translates to cut with water, because hydro means water and lysis means to cut. So in this process, enzymes attach to substrates that would later be broken down with water and then transform into free molecules, which are also known as free monomers. So this process is what breaks down the two compounds that make up PET. So what this diagram right here is showing is it's showing Ideonellus acaiensis right here, and it's showing how it breaks down the plastic in the water bottle. So as you can see, it breaks down the PET into the two compounds that it makes up, and then it eats the carbon from those two compounds, and then this cycle repeats and repeats until the bacteria can degrade the whole plastic. So these two are images. This first one is an image of PETase, the first enzyme that adenylyl uses to break down PET. And the second one is MHETase, which adenylyl uses this when PET is broken down into MHET. So this is what is used to help break down MHET into the two compounds which the bacteria eats, and then starts the process all over again. So the current status of adenylyl scientists have proven that adenylyl helps PET break down faster, but the process is still quite slow even with the help of bacteria. So PET specifically, it takes 450 years to decompose. So although that bacteria does help speed up the degradation process of PET, it doesn't do it in a time frame that is short enough. So what scientists are trying to do is they're trying to find optimal conditions that adenylyl thrives in to make the hydrolysis process faster and even more efficient. So the bacteria can break down PET in a shorter time frame, which we can see. So the discovery of a bacteria such as adenylyl allows for the possibility of improving the health of Earth to be even greater than ever. So as humans, we're the ones who unfortunately have contributed to this pollution. So it is only our responsibility to do something about this and to combat the immense amount of pollution before it is too late. And what adenylyl does is it allows for something to be done. If scientists are able to allow for adenyl to break down PET faster through the experiments and tests that they're currently doing, then we can move towards a cleaner world more quickly and more efficiently. So these are the sources that I use for my information and for my pictures. To whoever is judging, thank you so much for taking the time to watch my presentation, and I really hope that you enjoy my project. Thank you so much.